Or a rectifier. Yeah. And then this is a potentiometer, and I don't know what this is. So there.
Yeah, so you got your 110 coming in here.
Right.
You got that running over here. You got
To get to here.
Yep. So your white's your neutral. Your black is your 110. You got 110 current in. That's your ground wire.
Right.
And then coming out of there, you got.
Well, from the bridge.
Here's your DC motor. Green's usually ground. So that's your ground
Yes,
motor.
right.
And you'll have a red. And I knew it was DC and you show the picture because usually DC you'll have. Usually your color code will be red and black.
Okay.
So that'll be coming out, and you don't have in a DC circuit.
See, I knew you'd know more.
Little different deal. So DC circuit, you've got. Let me just pull this out. Let's see what we're doing.
After all the work I did to put that in there.
That's all right. Let me see what we're doing. I can see what I'm doing. So then we got red coming out of here, and you switched over to a white wire there. Not a problem. And you got black right there. So you got two power leads coming out of there.
Well, I had the color. Those are the colors I picked up when I reached in the wire drawer.
Yeah. So were you following? What was this from? This here?
I bought this on eBay.
Okay.
All three of those pieces were around $16.
So here's my question, without any identification on here. Was this blue wire and this black wire already connected here?
No, nothing was connected. All it was, pull all four of them out.
Okay. So you just decided to put the blue wire there and the black wire there?
I didn't know what to do.
Oh, okay.
I did. Okay. I just did decide that.
Let me see what markings, because there's no markings on here, which that's a little troublesome. But you got the idea. I mean, so you got, I'm noticing right here, you've got a plus sign, and it's a 5-watt AC. 5-watt AC, okay.
There's a plus on that one, which would mean nothing. But what that would indicate, in my opinion, I don't know, this would indicate that it goes to the motor because it's plus, and then this one is minus, right?
Yeah.
But those are interchangeable.
Well, on a DC, so what you're doing on the DC, what you're able to do with the DC here, the nice thing about DC is you've got your rheostat right here.
Right.
So basically what you're doing is you're taking 110 direct current in here, and you're able to vary. All this is basically, it's a transformer and a rectifier. So rectifier...
let's see, silicon or...
Yep, so what a rectifier does is, so 110 voltage coming out of your wall, it's AC, it's alternating current.
Right.
Which means it's operating in the United States on 60 cycles per
Right.
second. So every second you have 60 different full cycles of wave in that circuit right there.
Okay, agreed.
So what you're doing when you do a rectifier is you have diodes in a rectifier, and you have a full bridge and a half bridge rectifier. So the way a diode works is a diode lets the current flow one direction, but not the other direction.
That part I understand.
So when you build a bridge rectifier, what you're doing is you're basically every time, so a 110 volt current, it's like a sine wave. You think about sine wave. Mm-hmm. So you've got, it's always varying in voltage. You're going from 0 volts all the way up to say 110, and then at the top of that sine wave, you're at 110. Then it's decreasing in voltage. And then it goes to 0 at some point. But this is happening very fast. This is happening 60 cycles a second.
Right.
And then it's actually reversing. People don't realize that in an alternating current, the current's actually reversing. So on the top of the sine wave, the current is flowing in one direction. When it reaches the bottom of that point, 0, then it begins to flow the other direction. And you get it flowing backwards. And that's going all the way down to 110 volts as well. So you're oscillating between 110 volts at the high point down to it's not a negative, but the other side of the sine wave. So you're oscillating between 0 and 110 volts all the time. So what a rectifier does is a rectifier captures the top end of that sine wave, where the current's flowing in one direction, right? Captures that, and then as it starts to flow back the other direction, it doesn't let it flow back the other direction. And so when it comes down here, it flows back the other direction. So you build this rectifier, and so it's a series of 4 diodes and a 4-bridge rectifier. And basically what that does is it gives you steady state current or direct current, hence DC, right? So you're taking 110 volts and you're able to convert that to a steady form of current as opposed to alternating like that. So then what you can do with your rheostat is, it's just like a transformer, is you can vary the amount of juice I'll use that
And
word.
that's what the potentiometer
The
is.
potentiometer, it basically is a
Or-
rectifier. Yeah, or it's a rheostat is what it is. And so the potentiometer, the rheostat, is just varying the amount of voltage that you're allowing to go to that DC motor.
Okay.
So the nice thing about DC, it's very controllable. DC motors are wonderful. They're very controllable. They're using typically a lot less voltage, but more current. So for instance, this thing's probably, how many volts is this baby right here?
I don't know.
You're at two horsepower.
90.
Yeah, 90 volts. So you're 90 volts, but you're pulling 20 amps. So the nice thing about a DC motor is you can vary it very easily, which is why trains are all DC as well too, because you can vary. That's your throttle control right there. Is basically you can slow that baby way down or speed it way up where you want to.
Okay,
So.
but if you were to have this one running and an AC motor over here running the same saw, it would use more electricity here.
No, same amount. So what you're doing when you put it through a rectifier like that, or
Yeah.
a rectifier. What a rectifier does is it converts from AC to DC. But what a rheostat is doing is acting almost like a transformer. So what a transformer is doing is you're taking same amount of power, and if your transformer is here, right, you have voltage and current coming in here, which is how you get power. It's voltage and current. And coming out of here, you have voltage and current. So let's say you have 110 volts coming into here at, let's say, 10 amps, right? Coming out of here, maybe you want to step that up or step that down. That's what we call step up or a step down transformer. So maybe coming out of here, you want 220 volts. Not a problem. 220 volts it is, but your amperage is going to go way down, right? Because the same power in, power out. It's conservation of power. So the way that transformer works really nicely is you can step up, step down, which is wonderful. So theoretically, it's the same thing, whether you're same amount of power, so to speak. You're just doing it. You're utilizing it differently. Now, having said that, in real world, there's always losses. So every time you run through a transformer, it gets hot, and so you get heat loss in there. So it's not you're always gonna have a loss of energy in a system because the doggone thing heats up, which every electronic component does. So you run through a transformer, you're gonna get heat up. So, but basically here you got this thing popping in here at 110,
Yeah.
and you got your power lights coming out of here, going over here. Not exactly sure what this thing does right here, other than the fact it lets you hook all those four things together. Maybe it does something.
Oh, it's a bridge. It's got to give
That-
you the
Well, and
give you the
it may be a rectifier right there. So you might have, I don't know what
Okay.
components what without
yeah, and I don't know what
diving
that
into
other
it.
business is all about, but
Yeah. But that's the theory behind it anyway.
Yeah.
So have you plugged it in yet, or?
yeah, well, yeah,
Okay.
that's what I was going to show you. Oh, I can't show you. Well, I can show you something.
So the only thing I would do is your ground wire. So basically this guy on your plug right here, that's your ground wire right here. And your
Yeah, so we should. I know I should.
technically, I mean you got your ground coming in here like that. And not you're fine right now, but you'll want to eventually ground this
sure.
whole thing out.
Yeah,
you want
yes.
to ground this motor,
Yeah.
ground this, and you want to ground this platform, all that ground that whole baby together. Which you could do with just a simple, lug on there. You guys are good.
Oh yeah, I don't know about that. Okay, so we don't have the big pulley on here.
Yeah.
I don't know if you would like to see that. I could do that. We can take to it. But anyway, as you turn this on until it fires up.
Oh, that's nice.
And
You're going to be able to
this-
vary. That's so nice.
And this
Speed control.
will go at
Nice.
what did we figure? 'Cause we did
4.5 was the slowest we did when we turned it on the first time. And then we got it
More
up
than
to
that,
like
it was-
80. We figured maybe
I
80,
wish
60
I
to
could
80.
remember what I did. I can't even remember it now.
15 seconds.
For how many?
4.5 revolutions.
Oh, so
It's
then
slow.
It was 18 revolutions per minute on here.
Wow, that's going to be nice.
And that is slow enough so that then you have a cutting speed. The amount of blade that goes past is 80 feet in a minute.
In a minute. Yeah.
And cutting speed of low carbon steel is around 100.
Okay.
So
100
you
feet
can-
per minute. 100 feet per minute?
100 feet
Per minute.
per minute,
Per
and
minute,
that
okay.
goes whether you're turning a diameter or in this case, usually these are a little bit more forgiving because that tool doesn't stay in contact.
Yeah.
This one tool doesn't stay in contact with your work only for a millisecond.
Makes sense. Oh, that's gonna be
Anyway,
sick, guys.
and then you can speed that up.
Cutting wood. That's wonderful. Looking good, guys. Oh, see, and you got the beautiful thing, a DC motor,
I know,
speed.
yeah, you've got all of it.
You don't have to worry about changing belts.
I know it.
That's
Well,
great.
yeah, right.
That's great.
Once I got it geared down, and I mean, I had to gear this down, and I had to gear this down, but then I can get down to 18 as far as an RPM.
So what was part of the kit? These wheels came with the kit?
The
then?
wheels, the guides,
Nice. Oh, that is really
and
sweet.
then I don't.